Okay, so now that we've walked through how to get your data into Illustrator, um, we're going to kind of do a similar process, but look at CAD. And I did just want to note, make sure that you save this. I should have saved it like as soon as I started working on it because it comes in at a different file type, and you just want to make sure that you're saving it as an Illustrator file so that way you don't lose any progress. And you don't have to save that in the ArcGIS folder. You can then, do whatever you prefer in that case. Okay, so let's go back to GIS. I think let's do the same thing now, but let's get these contours into CAD. And this is where I said we needed to pay attention to the projection, which can get a little confusing, and I'm definitely not going to go too much in detail about all the nuances of the projection with GIS. Just give you the basics on that one. So we'll go back to analysis. And what we want to do is before we bring this into CAD, we need to make sure that it's the right projection, which is basically a mathematic formula determining how the computer is taking information from a 3D sphere and laying it flat on a 2D plane. So I mentioned you could right click on your layers and go to properties. And down in your source, you should be able to see what your coordinate system is set up. So sometimes it will, come in and it may not need to be changed, but definitely just check and make sure. And this can definitely be where we run into some issues. I typed in projection, but it's actually project. It's going to be this one. Kind of similar to clip. This is going to be, the layer that we're trying to get into CAD, or I guess in this case, we're trying to change the projection for. So I'm just going to do this UT campus contours. Also, another benefit of having clipped this now, I don't need to run through a huge data set and, have it take longer. And then, just make sure you're saving it. I would change the name um, to something like contours UT campus, and then I'm going to put it in the Texas state plane. So I'm just going to name it that so I know what it is, because it starts to get really easy to confuse these things together. Output coordinate system, if you had something in here that for sure was on the Texas state plane, you could just select that one and it would do the same thing. But here's how we're going to search for that, and it can be a little bit of a maze, but it should be the NAD 1983 Texas state plane. And if that doesn't show up, I'm just going to search Texas. And then it should be under this projected coordinate system, state plane. We've got the NAD. I typically want to do this one, the US feet. And, if you're unsure where you're, like which one of these you need to use, because there usually will be several, you can do a quick Google search or ask Chat GPT, and it should be able to confirm which one you should use. But I'm pretty sure it's this one for Austin. It's what we want to use. I'm going to select that. And then that should be all we need to do here. And I'll just click run. And basically what this is doing is it's just optimizing the data so that, if we're looking at a flattened version of this area of Austin, it's going to make sure that the data going from a sphere to a 2D surface is going to line up exactly with that. Okay, so we got our new projection here. We can go in here and check again, make sure it did it. Yep, here it is. Okay. Now we should be ready to go to CAD, hopefully. And this is where, like I said, you can run into some issues. It's definitely, in my experience, I've found that it's typically the state plane. that will line up, but you might have to do some troubleshooting if, once we pull this in there, it doesn't line up with any existing data that you have. You can try and find out if the CAD file was using a different coordinate system and then reproject this to whatever that coordinate system was. But I found that going with the state plane is kind of a good first check to make sure it lines up, and hopefully it will work. And so we're back on our geoprocessing tool, and we're just going to search CAD. And it's going to be this one, export to CAD. Input features, again, just going to drag my contours over here. If you have other ones that you want in here, you can do them at the same time. Just note that they're all going to come in on the same DWG file. Leave this alone. That's fine. Again, I would put this in my exports folder. And click run. And hopefully, we'll hope that it works. And all right, so I'm going to go to my folder. Oh no, where did I save it? See, this is where I mentioned earlier that it's important to pay attention to where you're saving your files. Okay. If you forget, you can go to this view details and it should have it in there. So I have it in my documents, GIS, projects, and this is where it will default save projects. And here we go is our export. So let's go ahead and open this EWG. That's fine. Okay, here's our contours. And if I had some other stuff in here, I'd be able to verify if that lined up correctly, but we'll hope that it did. And now you can go and edit this data in CAD, which is really useful for when you actually start designing things. You could either copy paste this over into your working file, or just save this and use it as an XREF